And that idea in the last chapter where I talked about some row changes, and we keep the rows that we talk about. So hopefully we'll get a little bit better at it within this chapter. So first of all, on 8.1, I want you to go into the book and I want you to fill in all of this vocabulary paperwork. On the second page, again, go into the book, fill all this information in. But I want to start with the matrices here, and we're going to create two matrices. The first one is called an augmented matrix, and an augmented matrix are the coefficients of each and the solutions. All right, so in this case, I would put the first equation is 1, -2, 1. Those are the coefficients. And then the answer 9. -1, 3, 0, because there is no z. -4. 2, -5, 5, and 17. Now, to prove that it's, or show completely that it is augmented, I'm going to put this little dashed line in front of that last column, because that dashed line symbolizes that this is augmented. These are coefficients. This is a solution. There's an x, y, z variable, and then this is the answer to it. The order of this is its dimensions, so it's 3 rows by 4 columns. Whereas a coefficient matrix is only the coefficients. It does not include the solutions. And a coefficient matrix of the exact same information is a 3 by 3. So we say two matrices are row equivalent if you can be obtained by doing interchanges, multiply by a non-zero, or if you can add a multiple of a row. So we're going to look at several of these. So on this one, you're given a matrix, and we're going to tell the rule that happened. So if I had 0, 1, 3, 4, blah, 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 and this is what I get on the second one, what happened? And we're always going to put the rule behind what we do. And what we did is we took row 1 and row 2 and interchanged them. So row 2 became row 1 became row 2, and we did nothing to 3. Okay? So now it says multiply the first row by 1/2. Okay, so here I have my first matrix, and I'm going to take half of row 1. Notice row 2 stays, row 3 stays, and row 1, I take half of it, and that's my new solution. This is going to be the rule that we use. You must write the rule. All right, on this next one, it says add -2 times the first row to the third row. So here what we're going to do is, because we're doing it to the first row, so it's -2 to the first row, add to row 3. Now this goes back to what we talked about in the last chapter. If I'm doing something to the first row, I'm first going to follow this -2, so that becomes -2, -4, +8, and a -6. In reality, when you do this, and when I see it on quizzes and tests, I would want to see this first. On the notes here, they kind of skipped that step. you would have left or multiplied by the -2, and you would have left row 2 and row 3 alone. Then you're going to take this and you're going to add row 3. Now we're going to take and change row 3, because we're starting with that row 1, which means we ended with it, because we, just like we said in the last chapter, we don't change the one that we're originally starting with. The second one we did nothing with, so it stays. And now the third one. So I take the -2 and 2, and I get 0. 1 and -4, -3. 5 and 8 for 13. -2, -6 for -8. We will do the Gaussian elimination with what's called back substitution. So here we have our equation. We're going to do this on the next page. So we're going to start with the augmented matrix. The augmented matrix, 1, -2, 3, 9, -1, 3, 0, -4, 2, -5, 5, and 17. Now our goal is to get to that at the very beginning where it talked about on the diagonal we want to get ones. So we want to get 1, 1, 1, and we want to get zeros in front of it so that we can get, hopefully at the end, we'll get this one number equals that one number, and then we can plug it in to solve it. So here's our augmented matrix of the 3 letters, 3 equations from the page before. Fortunately, it's going to give us the steps, and we're going to write the rule behind it. So we're going to add the first row to the second row. So we're going to take row 1 plus row 2. Now since we're doing row 1, that's the one we're keeping. So we keep it. And when I add row 1 and row 2 becomes 1, -1, -2, 3, 3, 0, 9, -4. And we did nothing to row 3. It stays. Okay, now it says add -2 times the first row to the third row. All right, so ultimately we're changing the third row, because that's the one it says that we're changing here. So we're going to take -2 times the first and add it to the third. So we're not changing the first row, but this is the rule that we're following. So -2 times the first row is -2, +4, -6, -18. And put that to the third row. This is just side work. We're going to get 0, -1, -1, -1. Now, we did nothing to the second row. It stays. And the first row is the one we kind of manipulated so that we could change the third. So it stays. I know it kind of seems backwards, but whichever one you're putting first is the one you don't touch. All right, so we're going to add the second to the third. So now we're going to say we're going to add the second to the third. So the second's the one we're not touching. The third one is the one we're changing. First one stays. Second one stays. So add the second and the third. I get 0, 0, 2, and 4. Multiply the third row by 1/2. So the third row by 1/2 or divide it by 2. First one stays, second one stays, and the third one divide by 2. So we get 1 and 2. Now keep in mind that last row is augmented. That means these are the solutions. So we would say Z, because that's the third location, is 2. All right. We call this last matrix the row echelon stair step. All right, so when all of the rows, what I want you to do is you're going to go into the book and you're going to fill this in. The one I really want to take note of is when we get to this Gaussian elimination, and that's the one we talked about before, is that there's a leading 1 in the position and zeros everywhere else. This is the one that we're going to do a lot more of. All right? The one we did before was a partial of that. We partially did that. We got to 1s and we got zeros below, but we didn't get zeros above. All right? And we're going to work towards that. But the way we do it is we follow these rules. So go into your book and get that all copied and filled in. All right, so here we have on page 6, we have 4 letters, 4 equations. The augmented matrix is all of the coefficients and the answers. Oops. X, Y, Z, W, and 2. X, Y, Z, W answer, X, Y, Z, W solution. So then this is our augmented. All right, again, this is going to work us through it. I would prefer to have the rules written behind, because that way you know what you stayed with, what you're changing, and what you get. That's how I want to see these done, but these notes are pre-printed before me, so therefore think of this being on the back side. Think of those being on the back side of the rules. So here we have our augmented matrix, and it says we want to interchange row 2 and row 1. So that's the only thing that's going to change. Everything else, row 3 and 4, are going to stay. Then it says I'm going to take -2 times row 1, and I'm going to add it to row 3. And I'm going to take negative times R1 and add it to row 4. So in both, again, to me, these would be 2 matrices. I only want you to do 1 rule per matrix. So for me, you should have -2 R1 plus R3 and have that result, and then you could do that result -R1 plus R4. However, we'll just stick within the confines of this printed worksheet. So if I take -2 times row 1, that means I'm not changing row 1. All right, and I'm not doing anything to row 2. So if I did -2 times row 1, I get -2, -4, +2, 0, and -4, and I'm adding it to row 3. And row 3 is 2, so that's 0. 4 is 0. -3 is -1. Where'd it go? Oh, how about 2 and 1 for 3? -3 and 0. And then -4, -2. Okay. If I do negative row 1, so that's -1, negative 2, positive 1, 0, negative 2, and add it to row 4. So that gives me negative 1, 1 is 0, negative 2, negative 4, negative 7, negative 1, negative 1, 0, negative 2, negative 19. All right, now it wants you to take 6 times row 2 and add it to row 4. So that means 1 is not changing. It means row 2 is not changing. It means row 3 is not changing. So 6 times row 2, 0, 6, 6, negative 12, negative 18. And do that to the row 4, we get 0, 0, 0, negative 13, and negative 39. So we're getting closer. We have some 1s and we have some 0s. We're getting closer. If I take row 3 and divide it by 3, row 2 doesn't change. Row 1 and 2 don't change. 4 does not change. 3 becomes 0, 0, 1, negative 2. Next one says row 4 is divided by negative 13. So the rest of them are not changing. Divide by negative 13, we get 1 and 3. So here we're getting much, much closer. We have zeros down below. We have 1s on the diagonal. So this is our row echelon form. I can now say W is 3. And I could substitute that in to the rest of these. I could say Z minus W, which is minus 3, minus 2. So Z minus W equals negative 2. So Z minus 3 is negative 2. So Z is 1. Then I could take that and move it up here. I could say Y plus Z minus 2W equals negative 3. So Y plus 1 minus 2 times 3. So negative 6, negative 5 added over, we get Y is 2. And then I could take all of that information and put it up to the top and get that X plus 2Y minus Z plus 0W is 2. So X plus 2 times 2 minus 1. So 4 minus 1 is 3. Take that over. We get negative 1. So once we get it to this, it's very simple to then go back and solve it. Like I said, we're going to do quite a lot of this. And you're just going to find the rule that works. There is no set pattern. You have to do it a certain way. It just has to follow the rules of solving a system. So on the last page here, the Gauss-Jordan elimination, instead of stopping when you get to the row echelon form, so instead of stopping here, because this is row echelon form, we're going to go so that we get not only 1s on the diagonal, but we're going to get 0s above the diagonal. Above and below the 1 diagonal is what this Gauss-Jordan elimination is. So at this point, this is a row echelon because we have 0s below and 1s on the diagonal. So I want to make above the diagonal 0s as well. And again, it's going to walk us through this process. So we're going to take 2 times the second row, which means the second row is staying. Third row is staying. And we're going to add it to row 1. So second times the row 2 is 0, 2, 6, and 10. So I get 1, 0, 9, 19. All right, now it says take negative 9 times row 3, negative 3 times row 3. So that means row 3 is staying put. Negative 9 times row 3 is 0, 0, negative 9, negative 18. And when I add that to row 1, I get 1, 0, 0, 1. Negative 3 times row 3 is 0, 0, negative 3, negative 6. And add that to row 2, 0, 1, 3, 5. I get 0, 1, 0, negative 1. This is augmented. So now, because it's in this Gauss-Jordan elimination here, 1s are on the diagonal, 0s are everywhere else. I can very clearly see x is 1, y is negative 1, and z is 2. Using these techniques in this section, you can still get systems that are infinite. And that's what I showed you on that last chapter, how that works with the infinite. But we're going to do a lot of practicing with this, and hopefully you'll see how efficient it can be.